You might have tried several times in your math career to learn factoring of quadratics, and maybe you were unable to get to the point where you're doing it really well. And once you do kind of manage to do it, a year passes and you've forgotten how to do it again. Okay? So this video is not to show you how to do factoring or how to do something that substitutes factoring. It's to explain why maybe it's not worth going through all the trouble of learning factoring now that you've tried to do it a few times and haven't really succeeded. Okay? So there's three main reasons. Okay? One of the reasons is that factoring does not work with quadratics that don't have nice whole numbers. So, for example, if you have this quadratic here, x squared plus 9.9x minus 1, okay, and you want to factor this, normal factoring procedure doesn't really tell you how to factor this. Okay, you could do workarounds like multiply by 10, but why go through all that trouble? Okay, so like quadratics like this, difficult to do factoring. Okay, so that's the first case. Second case, if you have a quadratic with a special characteristic as far as like the a, b, and c values here, which are the coefficients or constant terms, okay, I'm going to substitute in a combination which is not going to work as far as factoring goes. I'm going to put x squared plus 4x plus 1. And this looks really innocent, right? This looks like a quadratic that maybe you might be able to factor. But once you start trying to factor it, you'll realize there are no combination of numbers which makes this work, okay? And the reason why is, if you graph this quadratic here, it's a quadratic that does not cross the x-axis, okay? So it looks kind of like this. There's the x-axis here, and the quadratic is here. So the quadratic never touches the x-axis. If the quadratic never touches the x-axis, the quadratic is never equal to 0. Remember, when you're factoring, you're always trying to figure out what value of x makes it 0. Well, if the quadratic or if the parabola never touches the x-axis, it's never equal to 0. So you're never going to find a value of x which makes this 0, of course, right? So, so there are certain quadratic equations which you cannot factor. Okay, and those quadratic equations are these that correspond to a parabola that does not touch the x-axis. Sometimes it's on the top, sometimes it's on the bottom, but it does not cross the x-axis. Okay, and there is a way to figure out what we call a complex root of this equation. This parabola does not actually cross the x-axis, but there are imaginary numbers which can make this equation 0, okay? But we don't normally do that with factoring, okay? So again, so this is a second case that factoring doesn't work, okay? So in many cases, if you just like randomly write a quadratic equation like this, chances are you're going to accidentally write one that you can't even factor. Okay, so the ones in the book are very special cases, okay, of ones that you can factor. So if the instructions say factor this equation, then of course you're going to be able to factor it. It's a book problem or it's a test problem. But in real life, most of the time, you're probably going to get one that you can't factor, okay, or you're going to use a computer or something to do it. This leads us to the last case. Sometimes you get a quadratic equation which can be factored, but it's just kind of hard to factor because of the way the numbers are, and I'm going to give you an example here. If you look at this one, this looks pretty innocent, right? Let's say that we're trying to factor this. If we look at this, it's a little bit more complicated than the easiest problems, because not only do we have the 10 at the end, we also have the 6 at the beginning. So that means that not only do we need to list all the factors of 10, we also need to list all the factors of 6, right? Okay, and then, so like the combinations of, which one is the correct one. Only one of these is correct. Only one of these is correct. But the fact that we have like these two different combinations means that we have several combinations which might be correct, and we need to kind of like test them all to see which one's right. So it could be 1 times 6, 2 times 5. It could be 1 times 6, 1 times 10. It could be 2 times 3, 1 times 10. Or it could be 2 times 3, 2 times 5. Right? So there's like 4 possibilities here. And then after you get through kind of figuring out which one of these is correct, you still need to figure out if it's plus and minus. So like, for example, let's say, and I don't even know what's correct, but let's say that it's 2 and 3 and 1 and 10 or something like that, okay? And then we put the x's here, and we're almost done, but we still need to figure out, is it minus minus, is it minus plus, is it plus plus, etc., right? And we can tell from the signs here that it's going to be one of the worst cases, which is, if this is negative here, then that means that we need a minus plus combination. So it's going to be minus plus or plus minus. So now we need to try both of these combinations to see which ends up with negative 4, and then we might discover that we actually chose the wrong one here, and it's as you can see, it's trial and error, right? And so there's a lot of trying and error, and this is what makes factoring actually good, because like when you get a lot of experience with factoring, then you start doing a lot of stuff in your head, and you can discard things. You can start with the more likely possibilities, and then you start getting really efficient at factoring, okay? But it's kind of hard for, a middle school student or a high school student that doesn't really like math that much to get to this level of being able to factor really fast in their head. Actually it's kind of a puzzle that some people might enjoy doing. Now, if you have not enjoyed doing factoring so far, then I would say that maybe it's not for you, okay? And there is a way to avoid factoring, and so this video was just to explain to you why maybe you should avoid factoring, okay? As much as I hate to say it, as a math teacher, I think factoring, sometimes is kind of fun, but if you haven't enjoyed it up until now, then maybe you should watch the next video, okay?